What is going on, team? It is your friend Austin here with APSpace, and today we are going to configure a UART communication with an interrupt on a Photon 1 v0. So to begin, we go to the STM32 MX IDE. We go to File, New Project. We type in our part number that's on the Photon 1v0, so we're using STM32F722RET6. We click on the part, go to yes on default configuration, and then we have our microcontroller pinout. We go to System Core, Sys, Debug, JTAG 5 pin. We go to connectivity, we go to USART 1, we go to asynchronous, we go to NVIC settings, and we enable the USART 1 global interrupt. We have the other parameters as default, and then we go to USART 3, we go to asynchronous, we go to NVIC settings, and we enable the USART 3 global interrupts, and then we can have the other parameters remain the same there. And then we go to clock configuration, and then we set the clock to 216 megahertz because that is as fast as the clock will run. And then we're in project manager and go to file, save project as. We are going to save this project in a new folder that will be called Photon 1 v0 USART TX4. Save that. That fills in our project name and our toolchain folder location. We select MDK ARM for our toolchain / IDE parameter. We verify all of our settings. We save the project, and then we generate the code. We go open project, and then to make this process go faster, we're going to open a project we created earlier, and we're going to go to user code begin 0, and we are going to copy this block of code into our new project, and then we have our transmit array and our receive array, and we're moving this data into this array with a UART loopback connected to the Photon 1 v0. And then we go to user code begin 2, and we copy and paste to user code begin 2. And then we go to user code begin 3, and we copy and paste that to user code begin 3. And we go to project options for target Photon 1 v0 USART TX4. And then we go to use default compiler version 6. We go to OK. We go to rebuild, download, and then programming done. Verify OK means that the board was successfully programmed in this window here. So we're using the JTAG pins on Photon 1 V0, and then we plugged in everything on the J3 connector on Photon 1. And then we had everything plugged in because we selected 5-pin JTAG when we were configuring our pins, essentially. So we programmed that just fine. We go to start, stop, debug session. We highlight array 0tx, and then we go to add array 0tx to watch 1, and then we highlight array 0rx, and then we add array 0rx to watch 1. And then you go to reset, run, and we stop the program, and we see what is in array 0 tx, and then it's this string, and then when we see what's in array 0 rx, we see that APSpace is written to the array, and then we filled up the whole receive array when we transmitted the data over, right? So we go to main.c, and if we review essentially what we accomplished here, we saw that we declared 2 arrays, an empty array and a transmit array that had data in it. We initialized 2 counters, and then in the callback function, the UART callback function, we were reading 1 byte at a time from the array 0 TX transmission. And then when we initialized the UART, we initialized the UART communication with an interrupt with this function here. And then we essentially woke up the array with this while loop here. And initially we were reading 8 bytes to wake up the interrupt, the UART interrupt essentially. However, when we actually go into our while loop here, and we added this code, we're still transmitting the same while loop, but now in the callback function, we're reading 1 byte at a time. Now, why is this important? Well, this is extremely important because if we're receiving data from anywhere in the outside environment, right, we can add extra code in the callback function to where we can process the data 1 byte at a time. So if you're sending in some kind of key and you need some kind of key to unlock the microcontroller, or if you do some kind of combinational logic and you read 1 byte at a time, you can process the data in the same callback function or call to a different function within this function, right? So reading 1 byte at a time is really the best way to do the UART interrupt, and this is how the interrupt should be written ideally, in my opinion. Now, where do we get information on all this stuff? That's another very good question. So on my website, there's the Photon 1v0 development information folder, right? And that's free now. That's for free on my website. And something that's very important that's in there is the entire schematic for Photon 1v0. So not only if you want to do software, but if you want to make your own ST microelectronics board, this is an excellent reference schematic if you want to be an STM32 developer and you want to develop your own hardware. So I've kind of ironed out the wrinkles, if you will, on kind of just a evaluation board on an STM32, and this is a verified piece of hardware that has everything you guys need, and this is free on my website. So the schematic is there. What else do we have? We have all of the pinouts on Photon 1v0. We have a photo of the layout, and that is the development help that we have provided for an STM32F7. Hopefully this was a useful video for everyone, and you guys all have a wonderful day.